Here is part 2 of our 10-part series on complex numbers. We are going to understand operations with pure imaginary number I in this particular case. Many of the questions which we are going to discuss here can be seen in competitive exams. We'll begin with the basic concepts and answer these questions in a smart way so that you can answer most of them within few seconds, and that gives a competitive edge over others. We'll begin with the very first one, which is I to the power of n. So we need to first understand what is I to the power of n. So for that, write first 10 terms of I to the power of n and explore the pattern rule. As you know, the number complex number, the pure part of the complex number I to the power of 1 will be just I square is negative 1, I cube will be multiply negative 1 with I, you get negative I to the power of 4 is multiply negative I with I, you get negative I square, negative of negative 1 will be positive 1. Now, if you continue this pattern, will be seen here I to the power of 5 will be I to the power of 6 will be minus 1, I to the power of 7 will be minus I to the power of 8 will be 1. All multiples of 4 in the exponent will yield 1, right? So, since we want to put 5 numbers, 10 numbers, let's put I to the power of 9 and I to the power of 10. 9 should be I and 10 should be minus 1. Now, there's another way of looking into the complex numbers, and that is how do we plot them? Well, we have Argand diagram to plot the complex number. Just as you have a Cartesian plane where you have x and y axis. So here the x axis corresponds to real numbers. So I'm writing RE and the y axis corresponds to the imaginary number IM. So the unit here will be I along the y axis and 1 along the real numbers. So let's say we have a number which is 2 plus 3i. In that case, 2 is along the real axis. 3 times I means 1i, 2i, 3i. So we get a number right there. Let me use red ink for that. So this number here is 2 plus 3. You get the whole idea, right? So when we work on complex numbers, it will be represented by this line with its position at the origin. Perfect. So you can get from here the magnitude and also the direction of this particular thing which you're seeing on the screen, right? So I hope you got a fairly good idea from here. And also let's see how do the powers of I work here on the plane itself. You see this is I to the power of 1, correct? Which is I square, correct? I cube, and this is I to the power of 4, correct? Anything to the power of 0 will be 1, so that is what it is. As soon as you multiply by I, the point which was here moves to the imaginary axis and then rotates and comes down to negative 1 and then again goes to minus I and this rotation. As you can see from here, a pattern can be seen where the four values change. Perfect. So that's a visual look at what we are looking into. Powers of I. Multiplication by I is count counterclockwise movement by 90 degrees on the Argand diagram. Does make sense to you? That could be a competitive exam test question also. So I hope you have understood the concept, and with that, let's answer the questions. Right. Well, in case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are doing extremely well, getting admission to the best universities, even with scholarship. You can be there. So now the question here is I to the power of 1999. Well, we know it is like I to the power of 2000, right? It is not a multiple of 4. However, we can see that this is I to the power of 2000 minus 1, right? That means it should be equal to I cube, which is minus I. And therefore, we have option C as the right option. You get the whole idea. Even if you are visualizing it on the Argand diagram, this point I to the power of 1999 will be right there, which is minus I. Hope it makes sense. Many times this diagram helps. So, with this concept in mind, let us answer the questions. So, here, if A, B, C, and D are consecutive positive integers, what is the value of I to the power of A plus I to the power of B plus I to the power of C plus I to the power of D? So, basically, we are looking for the four numbers in sequence, right? So that is to say, you could say I to the power of 4, I to the power of 5, I to the power of 6, I to the power of 7. Correct. Visualize, right? So you are there at 1, and then you go to, and then you get minus 1, and then you get minus I, right? The four positions, correct? And when you add them up, you see addition will bring you to 0, right? And therefore, option A is the right option. It doesn't take more than few seconds, right? Now, the next question is, what is the product of these numbers? Basically, we are now multiplying 1 with I with minus 1 and minus I, correct? So when you multiply, you get what? 1 times minus 1 will be minus 1, and I times I, there's negative here, negative I square, correct? So we are landing up with three negatives, negative 1 times negative, and I square is also negative 1, correct? So you multiply three negative ones, you get negative 1 as your answer. Makes sense, right? So when you multiply them, four consecutive powers, in that case, you get minus 1 as the result, right? Since multiplying 1 and minus 1 will give you minus 1, here we have minus I square, right? Minus I square is again negative 1. So three negatives will give you a negative number. Hope it is absolutely clear. So the next question here is if I to the power of A equals to I to the power of B, which of the following is always true? We are given four options, and clearly, what we are looking for is when are they equal, right? So, I to the power of A equals to I to the power of B. So, they are always equal when we are multiplying 4, right? So, it is not that A times B is 4. That could create a confusion. It is that they are apart by multiple of 4. Correct. So difference between A and B should be a multiple of 4, right? Every multiple of 4 is not, every multiple of 2 is not a multiple of 4. So D is also a wrong answer. You get the whole idea. So it's a very good question. Sometimes students get confused while answering this question. So we have made a variation to this question now. And here we're saying if, so here is a new question for you. If absolute value of I to the power of A, absolute value, is equal to absolute value of I to the power of B, in that case, what is true? Now you can see, if you see the pattern, what you really notice is that you have, let's say, I minus 1 minus I and plus 1, right? Then again, it is I minus 1 minus I and plus 1. So in that case, you see the even numbers absolute value will be I, correct? Absolute means positive. And therefore, for this, the correct option is option D. Does that make sense to you? Perfect. So, with that, we have answered all the questions which we wanted to in this particular video, and that really helps you if you are also taking SAT tests soon. And our advice for all the students is earlier the better. So, take SAT in grade 11. Do not wait till grade 12, since you need to apply to the universities. And by the time you graduate from the school, you should have admission in hand, and that is possible only if you give 1 year time for the university to process your papers. Makes sense, right? Second, it is not just the marks which help you, it is also recommendations. So work on your recommendations letters also. Always, when you want to do something, plan and then practice with the best resources. Always feel free to ask questions. We can help you. Education is all that matters. It really makes a huge difference. So feel free to contact us on globalmathinstitute@gmail.com. We have hundreds of videos for you on every topic of your interest. We can send a link for these free videos that can help. With that, we come to an end of this part 2. Explore more and learn. Thanks and all the best.